Hello everyone. So today we are going to study real numbers, which is the first chapter of your class 10th mathematics. So the question is, what are real numbers? And are there any unreal or imaginary numbers as well? And you'll be studying about all of them if you take up mathematics in your higher studies. But to answer a real question, which is what are real numbers, the answer is that any number which can actually be represented on a number line is a real number. So what is a number line? Now, to find the answer to that, we have to understand that a number line is just a horizontal visual representation of the real numbers which are placed at equal intervals. So you see the distance between -1 and 0 is same, 0 and 1 is same, 1 and 2, 2 and 3 and so on. The distance between each of these digits is exactly the same. And the best part about the number line is that it extends infinitely in both directions. Great. Now, as you're already familiar with the concept of irrational numbers, so you know that some of them, like pi, are tricky to plot. Hence, we can only take their approximate value. So, such numbers, which nevertheless are actually real, they still cannot be represented very easily on a number line. Now, you see that there are natural numbers which are 0, 1, 2, and 3. Then the bigger circle, which tells us all the integers are a part of it. Then we come to the rational numbers, which are all the fractions, as you can see. Then real algebraic numbers, which are under roots of everything, like under root 2, under root -3, 1 plus under root 5, and all of them. And then the real number, which are pi, the power of e, -2 pi, and all of that. Now all of these numbers, the natural numbers, integers, rational numbers, real algebraic numbers, all of them combined give us real numbers. Great. Now let's head to our first topic, that is Euclid's division lemma. Now let's break this entire word. So Euclid, who was this? This person is a mathematician. I'm sure that all of you know what is division, but the question is, what is lemma? So now Euclid is a name, division, we all know what is division in mathematics. Now what is lemma? Now lemma is a proven statement used for proving another statement. What is lemma? It's a proven statement. So there was a statement which was already proved. Now that particular statement is being used to prove other statements. And that is what the word lemma means. Now the question is, what is Euclid's division lemma? The Euclid's division lemma states that given positive integers a and b, there exist unique integers q and r satisfying a is equals to b into q plus r. Now don't get confused, this might seem very different from what you have learned in the past, but a is equals to b into q plus r is just stating dividend is equals to divisor into quotient plus remainder, and I'm sure all of you have already read about this, learned about this, and have solved countless questions in the past. But here the catch is that the remainder cannot be greater than divisor, and this is important to note for solving questions in future. Great. Now let's look at the first question. It states, example number 4 from the NCERT, it states a sweet seller has 420 kaju burfis and 130 badam burfis. Now she wants to stack them in such a way that each stack has the same number. So each stack has the same number, that's important part, and they take up the least area of the tray. Okay, so you have to find that each stack has the same number and all of them take up the least area of the tray. Now we have to find what is the number that can be placed in each stack for this purpose. Okay, so to solve this, we have to find the HCF of 420 and 130, and we are going to do that by using the long division method. Okay, so here this states 420, that's a dividend, and 130 is our divisor. Now 130 into 3 would give us 390, leaving us with the remainder 30. Okay, because the long division will keep on dividing it until our remainder is 0. Now for 30, now our dividend becomes 130, which was earlier our divisor. Now 30 into 4 is 120. Now this brings us here. This brings us to 10. Now 30 becomes our dividend. And now 3, this gives us the remainder 0. Now let's take the Euclid's division lemma that we just learned. Okay, for 420 we have divisor, which is 130, into quotient, which is 3, plus remainder, which is 30. This gives us 390 plus 30, which gives us 420. Great. Similarly, for 130, what we can do? It's 30 into 4 plus 10, which gives us 130. What about 30 last? For 30, it's 10 into 3 and the remainder, which is 0. So this gives us 30. Great. So this is also actually proving a Euclid's division lemma that we just saw and learned about. Great. Now our HCF for this is 10. This means that Kaju Barfis and Badam Barfis should be stacked in the number of 10 so that they require the least area of the tray. Great. Now let's look at the solution from the NCERT. So this is the solution from NCERT, and all they did was also to find out the HCF, and they did using the Euclid's algorithm that we used also here. Great. We can also do it by long division Euclid. We can do it by this. Any way which you are comfortable with will work. Great. So you can take a screenshot of it if you want, else it is also present in your books for you to look at. So as you can see, so the HCF of 420 and 130 is 10. Therefore, the sweet seller can make 10 stacks of 10 for both kinds of barfi. Great. Now let's move on to our next question. It states, use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. Okay, so let's take any term. Let's take any term x. Okay, now I can write x as 3 cube. Okay, and if I want to take a cube of it, I will take x cube equals to 3 cube. This comes out to be 27 cube. Great. Now I can write 27 cube as 9, then 3 cube. Now if I point out as 3 cube to be m, then this becomes 9m. So we have satisfied the first part of it. Great. Now if I put x, so now if I put x as 3 cube plus 1. Okay. If I take a cube on both sides once again, this becomes 3 cube plus 1 whole cube. Now x cube becomes 27 cube plus 27 q square plus 9q plus 1. Now let's take 9 out of it because that is how we are going to do it. So let's take 9 out of it. So this becomes 3q cube plus 3q square and plus q. Now 1 is there, left alone, so we are going to add 1 at the end. Once again, let's take 3q cube plus 3q square plus q as m. So this becomes 9m plus 1. So 9m is proved, 9m plus 1 is proved also. Now let's try to find it for 9m plus 8. Okay, great. Now this time I am going to take x as 3 cube plus 2. This time x cube will give me 3q plus 2's whole cube, which comes out to be 27q cube plus 54q square plus 36q plus 8. Now x cube once again can be rewritten as, if we take out 9 as common, 3q cube plus 6q square plus 4q and then 8 at the end. Now I am sure that you already know what I am going to do here. I am going to take 3q cube plus 6q square plus 4q as m. Therefore x cube comes out to be 9m plus 8. So we have also proved the third part of it. So all these three are proved. Now you must be thinking that why did we only use 3 cube till 3 cube plus 2? I can also take 3 cube plus 3, 3 cube plus 4. But if you look at this statement, x is equals to 3 cube plus 2. This is basically in the same form as a is equals to b cube plus r, and all of us know that r needs to be greater than or equal to 0 but less than b. So it would be less than b, and because of that we know that our b here our b is equals to 3. Therefore this cannot be more than 2. Great. Now this solves this question. How do we use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 and 9m plus 8. Great. Now you can see the solution here. Again the same they did, so they pointed out this note in the very start that why did we take b only till 3. Now you can take a screenshot of it if you want, or you can take a screenshot of the previous slide that has solved the question for all of you. Great. Now these two, again the solution is continued, and thus x cube for any positive integer can be written in the form of 9m, 9m plus 1 or 9m plus 8. Great. Now let's move on to the next part. Now this states the fundamental theorem of arithmetic. So now we are going to talk the fundamental theorem of arithmetic. Now it states that every composite number can be expressed, this means factorized, as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. What do we understand by this? Let's complete the statement, then we will be able to have a better idea. So actually it says more. So it says that given any composite number, it can be factorized as a product of prime numbers in a unique way except for the order in which the prime numbers occur. For example, we can write 6 as 2 into 3, which is both of them are prime numbers and 6 is a composite number. If I talk about 10, it then becomes 2 into 5. As you see, these are a unique set of prime numbers, and here it's a composite number. And I'm sure you'll be able to understand it much more clear when we start solving questions on these. For example, you can see it here. So here there is a composite number which is 760. Now, our first prime factor for this is 2. This comes out to be 16380. Again, dividing it by 2 will give us 8190. Once again, our prime factor is 2, which is give us 4095. Then by 3, then 5, and at the end by 7. So this means what I can write 32760 as 2 to the power 3 multiplied by 3 to the power 2 multiplied by 5 multiplied by 7. As you can see, all of them are unique set of prime numbers through which we are actually expressing a composite number. Great. And also you see, this is obviously one method of doing prime factorization. You can also do the basic method that we do, that we write 32760 here, and then we start by doing this 16380. Then we again divided by 2, this is give us 8190. Once again by 2 would give us 4095. This time by 3 would give us 1365. Once again by 3 would give us 455. This time by 5 would give us 91, and at last by 7 would give us 30. So here again 2 is 3 times being repeated, 3 by 3 2 times, 5 1 time, and 7 1 time. So both of the ways, whichever you are comfortable with, you can do in the examination. Great. Now let's move on to our example number 8. It states, find the HCF and LCM of 6, 72 and 120 using the prime factorization method. So you have to write 6, 72 and 120 as a series of prime factors. How do we do it? Let's take prime factorization. For 6 we have 2, 3 is 6, and then 3 is 3, 1 is 3. Okay, so there are the prime factors are 2 into 3. What about 72? Let's try to do it. For 72 we have 2. So first we'll go like 2, 3 is 6, and then 6 is 12, so 36 here. Then it's 18, and 2, 9 is 18. Then for 9 we have 3 is 9, and at the end 3 is 3. So for 72 we have 2 3 times, while 3 2 times. Okay, great. What about 120? For 120 what we can do is 2, 6 is 12, and then 0, 2, 3 is 6, and then 0, then 2, 15 times is 30. Then for 5, the lowest prime factor that would divide 15 is 3. So 3, 5 is 15. And for 5, as it's a prime number, you will use 5 once again. This becomes 1. So for that, we have 2 to the power cube into 3 and into 5. Now the question is how to find the HCF and LCM from this prime factorization that we just did. Now for LCM, we have to take the least power of all the prime factors, of all the common prime factors. So first let's find out the prime factors which are actually common in all of these. So 2 is common in all of them and 3 is common in all of them. Okay, now we have to take the least power of all of them. For the least power, we see that for 6 it's 2 is to power 1 and 3 is to power 1. And other than else, everywhere the power is more than 1, except in 121 where once again 3 has only the power of 1. Okay, great. This means the HCF of this is 2 into 3, which comes out to be 6. What about LCM? Now LCM goes against, it's completely opposite. This time we have to take all the possible factors. They don't have to be the common ones. So if even it's just repeating one time, then we are still going to take it. So for that we have 2, 3 and 5. So all of them will be present here. Now the question is, what about the powers? This time the maximum powers of each will be taken. So we can see the maximum power of 2 in all of this is 3. The maximum power for 3 is 2 and for 5 it's 1. So this comes out to be 8 into 9 into 5, which is 72 into 5, which comes out to be 360. Okay, great. So our LCM is 360 while our HCF is 6. Once again, you can see the solution here for yourself. You can take a screenshot of this, or else it is also present in your NCERTs. So whichever way is comfortable for you. Great. Now let's move on to the next question. So here it states that there is a circular path. So there is a circular path around a sports field. Now Sonia takes 18 minutes to drive one round of the field. Okay, so Sonia takes 18 minutes. Let's write here Sonia and let's write 18 after here. While Ravi takes 12 minutes for the same. So Ravi takes 12 minutes. Now supposing they both start at the same point at the same time. Okay, Sonia and Ravi both are here and they are starting at the same time at the same point. And they go in the same direction. So assuming that they are both going in this direction for now. Now after how many minutes will they meet again at the starting point? Okay, so now we have to find out after how much time they will meet again at the starting point. Now for this to solve, we have to find the LCM of 18 and 12. Once again, let's use the prime factorization method. Let's put 18 here and 12 here and try to find the factors. Let's do it for 18 first. So it's 2, 9 is 18, 3, 3 is 9, and 3, 1 is 3. So 2 and 2, 3 to the power 2. What about 12? For 12 it's 2, 6 is 12, 2, 3 is 6 and 3, 1 is 3. This time 2 to the power 2 multiplied by 3. Okay, great. So now let's do the HCF. Now let's do the LCM. Sorry. Yes. For LCM, we are going to take all the factors with the highest power possible. Okay, so what is the highest power? So let's take all the factors first. So the factors are 2 and 3. And what is the highest factor? The highest factor for 2, the highest power for 2 I mean is 2, while the highest power for 3 is also 2. So this comes out to be 4 into 9, which is 36. So this means that Sonia and Ravi will meet together again at the starting point after 36 minutes. So this is your answer. Great. As you can see the solution here, you see that they both started at the same point A, then we took the LCM of 18 and 12 and we could find out that after 36 minutes, they will be meeting again at the starting point. Now this brings us to the end of our first video for real numbers, and in the next video we are going to discuss irrational numbers. I hope you learned everything and understood what we have done till now with the HCF and LCM part. I would highly recommend you to solve tests on the EduRev platform and go through the document of irrational numbers before watching the video. Thank you so much everyone. Have a happy learning with EduRev.